By 2030, humans could very well be living on Mars. This isn't science fiction, it's a fast-approaching reality. Over the past years, companies like SpaceX and NASA have made tremendous strides toward making Mars colonization possible. SpaceX's Starship, a spacecraft designed for long-duration flights, aims to transport the first settlers to the Red Planet within this decade. This ambitious goal is driven by the vision of transforming Mars into a self-sustaining colony. Imagine waking up one day in a habitat on Mars, looking out of a window and seeing the Martian landscape instead of Earth's blue skies. This thought alone is enough to spark excitement and anticipation for what could be humanity's next giant leap. The journey to Mars itself is a colossal undertaking. It takes about 6 to 9 months to travel the 225 million kilometers from Earth to Mars, depending on the positions of the planets. Once there, settlers will face challenges unlike any encountered by previous explorers. The Martian atmosphere is thin and composed mostly of carbon dioxide, making it unsuitable for human life as it is on Earth. To survive, humans will need to create enclosed habitats with controlled environments. These habitats will be equipped with life support systems to provide breathable air, potable water, and nutritious food. One crucial technology for Mars colonization is in situ resource utilization, or ISRU. This involves using the available resources on Mars to produce water, oxygen, and fuel. Since shipping these necessities from Earth is impractical and expensive, ISRU will be key to sustaining life on Mars. For example, engineers are developing methods to extract water from the Martian soil or ice, which can then be split into hydrogen and oxygen through electrolysis. The hydrogen can be used as fuel, while the oxygen provides breathable air. This self-sufficiency is vital for the long-term success of any Mars colony. Power generation on Mars presents another significant challenge. Solar panels are an obvious choice given Mars's distance from the Sun. However, the planet's frequent dust storms can obscure sunlight for days or even weeks. As a result, nuclear power has emerged as a promising alternative. Compact nuclear reactors can provide a steady and reliable source of energy, ensuring that habitats remain powered even during prolonged dust storms. Communication with Earth will also be a hurdle. The average communication delay between Earth and Mars ranges from 3 to 22 minutes, depending on the planet's relative positions. This delay makes real-time communication impossible, requiring Mars settlers to operate with a high degree of autonomy. Advanced artificial intelligence systems could assist in managing daily tasks and decision-making, reducing the dependency on Earth-based support. Healthcare on Mars will need to address the unique challenges posed by the Martian environment. The low gravity, which is about 38% of Earth's gravity, could affect human physiology in ways we don't yet fully understand. Prolonged exposure to low gravity may lead to muscle atrophy and bone loss. To combat these effects, habitats might include exercise facilities specifically designed to help maintain muscle and bone strength. Additionally, medical facilities will need to be equipped to handle emergencies, surgeries, and long-term health care, potentially with the aid of robotic surgeons and advanced telemedicine. Looking further ahead from 2030 to 3000, the vision is even more expansive. As technology advances, we could see the establishment of large, thriving Martian cities. These cities might be built entirely underground or within massive biodomes to protect inhabitants from radiation and extreme temperatures. Advanced terraforming technologies could one day make parts of Mars more Earth-like, creating areas where humans could live without the need for enclosed habitats. Terraforming Mars is a monumental task that would likely span centuries. It involves altering the planet's atmosphere and surface to make it more hospitable for human life. Scientists have proposed various methods such as releasing greenhouse gases to warm the planet and thicken its atmosphere, or redirecting comets to impact Mars, delivering water and other essential elements. While these ideas are still theoretical, advancements in technology could turn them into reality over the next millennium. Mars colonization also raises important ethical and governance questions. Who will have the right to govern a new Martian society? How will resources be shared, and what laws will be in place to ensure fairness and equity? These questions need careful consideration to avoid repeating the mistakes of past colonial endeavors on Earth. The cooperative and inclusive approach, possibly overseen by an international organization, could help ensure that Mars colonization benefits all of humanity. In conclusion, the future of Mars colonization from 2030 to 3000 is filled with incredible possibilities and challenges. By leveraging advanced technologies, innovative solutions, and a spirit of cooperation, humanity can establish a thriving presence on Mars. This bold venture not only represents a new chapter in human exploration, but also holds the promise of ensuring our species' long-term survival. The dream of living on Mars is no longer a distant fantasy, it's becoming an achievable reality. Let's embrace this future with excitement and determination.